For decades, we've searched the stars for signs of life. Thousands of planets, billions of galaxies. So why haven't we found anyone yet? It's one of the most profound questions humanity has ever asked. We look up at a night sky filled with countless stars, each potentially hosting its own system of planets, and we can't help but wonder, are we alone? The numbers alone suggest the universe should be teeming with life. Yet when we listen, all we hear is silence. Back in 1950, during a casual lunch conversation, the brilliant physicist Enrico Fermi posed a simple but powerful question that has echoed through the halls of science ever since. Where is everybody? He wasn't just making small talk. Fermi had done a quick mental calculation. Given the vast number of stars in our galaxy, the high probability of planets orbiting them, and the billions of years the universe has existed, there should be countless technologically advanced civilizations out there. So if the math says the galaxy should be a bustling cosmic metropolis, why haven't we detected a single sign of alien life? No radio signals, no megastructures, no alien probes. This glaring contradiction between high probability and the complete lack of evidence became famously known as the Fermi Paradox. Let's break down the scale we're talking about. Our own galaxy, the Milky Way, is estimated to contain anywhere from 100 to 400 billion stars. Recent discoveries from telescopes like Kepler have shown us that planets are not the exception, but the rule. It's now believed that there could be over 100 billion planets in the Milky Way alone. A significant fraction of these are likely rocky planets residing in the habitable zone of their star, that sweet spot where conditions might be just right for liquid water to exist on the surface. If even a tiny fraction of those planets developed life, and an even smaller fraction developed intelligent life, our galaxy should still be filled with civilizations. And many of these would be millions, if not billions, of years older and more advanced than our own. Yet the cosmic airwaves are silent. The silence is deafening, and it forces us to confront some uncomfortable and fascinating possibilities. So, where could everyone be? Let's explore the first and perhaps most humbling explanation. What if life itself is just incredibly astronomically rare? This idea is known as the rare Earth hypothesis. It suggests that the emergence of complex, multicellular life on Earth wasn't just a matter of being in the right place at the right time. Instead, it was the result of an extraordinarily long and improbable chain of events. Think about it. We needed a stable, long-lived star like our Sun. We needed a planet of the right size, with a protective magnetic field to shield us from solar radiation. We needed a large moon to stabilize our axial tilt, giving us predictable seasons. We needed the presence of giant planets like Jupiter to act as a cosmic bodyguard, sweeping up dangerous asteroids and comets. We needed plate tectonics to regulate our climate and recycle essential chemicals. The list goes on and on, from the specific chemical composition of our crust to the very specific timing of evolutionary leaps. According to the rare Earth hypothesis, the confluence of all these factors might be so statistically unlikely that it has happened only once in the entire galaxy, or maybe even the entire observable universe. If this hypothesis is true, it changes everything. It means that when we look out at the stars, we aren't looking at potential neighbors. We are looking at a barren, empty cosmos. It would mean that this tiny blue dot, our Earth, isn't just special, it's a miracle. We could be the only ones watching the stars, the sole consciousness the universe has managed to produce. The weight of that thought is immense. It would make our responsibility to protect this unique flicker of life not just important, but sacred. But what if we're wrong? What if the opposite is true? Let's consider another possibility. Life is common, but it's also incredibly fragile. Perhaps the universe is a cosmic graveyard, filled with the ruins of civilizations that rose and fell long before they could make their presence known on a galactic scale. Under this theory, the jump from simple life to a spacefaring, communicating civilization is fraught with peril. Think of all the hurdles a species must overcome. On a planetary scale, there are natural disasters, supervolcanoes, catastrophic asteroid impacts, or nearby gamma-ray bursts that could sterilize an entire planet in an instant. Evolution itself is a gamble. There's no guarantee that intelligence is an inevitable outcome. And even if a species does become intelligent and develops technology, it then faces a new set of self-inflicted dangers. Nuclear war, irreversible climate change, runaway artificial intelligence, or engineered pandemics could all serve as great filters, wiping out a civilization before it ever masters interstellar travel or communication. Perhaps civilizations are like cosmic fireflies, blinking in and out of existence in the vast darkness of time. They might thrive for a few thousand or even a few 100,000 years, a mere blip on the cosmic timescale, before they succumb to one of these filters. From a galactic perspective, the chances of two civilizations existing and being technologically capable of communicating at the exact same moment in time might be incredibly slim. We could be listening for signals from civilizations that died out millions of years ago, or waiting for signals from future civilizations that haven't even been born yet. It's a sobering thought. The universe might be full of life, but it's a life that's transient and fleeting. Now, let's venture into a more speculative and perhaps more unsettling territory. What if advanced life is out there, and it's not rare or extinct? What if it's hiding? This leads us to another concept tied to the Fermi Paradox, the idea of a great filter that might not be in our past, but in our future. Or perhaps it's a conscious choice made by those who have passed through it. This is the zoo hypothesis, or the dark forest theory. The zoo hypothesis suggests that advanced civilizations know we're here, but they have deliberately chosen not to interfere. They might be observing us from a distance, treating Earth like a cosmic wildlife preserve, allowing our civilization to develop naturally without outside influence. We would be like uncontacted tribes in the Amazon, completely unaware that a wider, more advanced world is watching us. They might be waiting for us to reach a certain level of technological or ethical maturity before making contact. Then there's the more ominous dark forest theory, inspired by Liu Cixin's science fiction novel. In this scenario, the universe is like a dark forest filled with hidden hunters. Every civilization is a potential threat. Broadcasting your existence is a foolish and potentially fatal mistake, as it could attract predators who see you as a competitor for resources or a future danger. The safest strategy, therefore, is to remain silent, listen, and eliminate any civilization foolish enough to reveal its location. In this terrifying scenario, the cosmic silence isn't because the universe is empty. It's because everyone is hiding in fear. They might even exist in forms we simply can't comprehend. What if an advanced civilization has transcended its biological origins, existing as pure energy, or living within black holes, or in extra dimensions our senses can't perceive? They wouldn't need to use something as primitive as radio waves. They might be all around us and we would be completely oblivious. Maybe they see us, but we'll never see them. Despite the silence, the search continues, more determined than ever. We're no longer just passively listening. We are actively looking. Through powerful radio signal arrays like the Allen Telescope Array, we scan the skies for any artificial transmission that stands out from the cosmic noise. Deep space telescopes, most notably the James Webb Space Telescope, are revolutionizing our ability to study the atmospheres of distant exoplanets, searching for biosignatures, the chemical fingerprints of life, like oxygen or methane. We're sending probes and rovers to explore our own cosmic backyard, from the rusty plains of Mars to the icy moons of Jupiter and Saturn, looking for even the simplest forms of microbial life. Each new planet discovered, each new signal analyzed, and each new image from deep space brings us one step closer to an answer. We don't know what that answer will be. Will we find that we are utterly alone, the sole custodians of consciousness in this vast expanse? Or will we discover that we are part of a grand cosmic community, far greater and older than we can imagine? Either outcome would fundamentally change our understanding of our place in the universe. The silence of the stars is not an end, but a beginning, an invitation to keep asking, keep exploring, and keep reaching for the truth. The stars hold secrets we've only just begun to uncover, and the answer to Fermi's question could be the greatest discovery of all. If you're as fascinated by these cosmic mysteries as we are, make sure to subscribe and hit that notification bell. Join our mission as we continue to explore the unknown universe together. Thanks for watching, and keep looking up.
Cosmic secrets revealed. Beyond time, beyond space, beyond imagination.